episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. Quick question. When was the last time that this has happened? Specifically, this referring to two back-to-back Operation Core Dump episodes. To be honest, I'm not sure if it has actually happened before or not, but like another thing we will talk about later in this episode, there is a first time for everything, I suppose. But before we get into all the goodness of this week's episode, let's start off with our trivia question for the week. So CPU stands for Central Processing Unit, and GPU stands for Graphics Processing Unit. But what does APU stand for? So again, what does APU stand for? And that is your trivia question of the week. So have you guys ever had bacon maple glazed donuts before? If you haven't, I definitely highly recommend them since they are very good. But one thing you do have to be cautious of if you do end up getting one is you have to eat them fresh. Otherwise, the bacon can potentially get kind of soggy and no longer be crispy, and it kind of loses some of its appeal. Now, you might be wondering why a technology-focused podcast is talking about donuts right about now. Well, first off, if you happen to be the guy or gal that brings in donuts into your office, you will, without a doubt, be the hero of said office for the day or so, because I think everyone can agree donuts are pretty fantastic. But no, the real reason that we are talking about donuts today is because one of the most famous donut places in the U.S. suffered a cyber attack recently and has been disrupting online orders this week. So a little donut company that you may or may not have heard of, known as Krispy Kreme, suffered a security incident this week. But I think the BBC probably has to take the cake for the best headline when it comes to this, because their headline was "Hackers Find Hole in Krispy Kreme Donuts Cybersecurity." So starting off this episode with the pun, you gotta love it. But the details are pretty sparse into specifically what happened. But the reason why we even know that this kind of happened in the first place, in addition, I guess, to the fact that people are having issues placing online orders, is since Krispy Kreme is a publicly traded company, they had to file and submit a K-8 filing with the SEC in order to disclose this incident. I guess because if my understanding is if you have something happen that could potentially impact your stock price, you're supposed to report things like that through this K-8 form to the SEC. So that's kind of how we know about it. And the company did make a kind of sort of remark, although they haven't really talked too much about it. But they did say, quote, "As the investigation of the incident is ongoing, the full scope, nature, and impact of the incident are not yet known. But the main disruption that we do know of, at least so far, is online orders being kind of the main thing. But there's still kind of unknowns into if this was maybe a ransomware attack, if there was any kind of theft of IP, or if there was some kind of networking issues that kind of got spun up. Like, we don't really know. We just know that online orders are having some issues. But if you are a donut aficionado, rest assured you can still get your Krispy Kreme. You just have to actually go to Krispy Kreme or somewhere where Krispy Kreme is actually sold, since they're still able to process orders in stores. And then, of course, if you go to some other chained place that sells Krispy Kreme donuts, you could still get them there. It's just the online orders that are the issue. But to be honest, though, it may be for the best anyway that you have to actually physically go out and get Krispy Kreme donuts, because with how many junk calories are in donuts, the little extra exercise you get is probably good anyway. Now, don't get me wrong. I do enjoy myself a donut as much as the next guy, but I think we can all agree that they aren't exactly the most. The calories that you get from them aren't exactly the best. I think we can all agree on that. But speaking of cybersecurity incidents, let's get into this week's cybersecurity tip. This week's cybersecurity tip is to make sure your programs aren't spying on you. And I think it goes without saying that at this point, if you're not paying for the product, you are the product. In other words, if you aren't paying for a service and the service is given to you for free, the data that you provide to said service through your usage or data you willingly provide is being sold to advertisers, and you are the product. The most classic example of this, of course, is social media. Social media is free for everyone to use, but of course, every interaction you do, every kind of post you hang around for a little longer than normal on, anything you upload personally, all that data is being harvested and sold to advertisers. So your data is the cost of admission, if you will. But nowadays, even the paid services aren't safe from selling user data. So I guess having the subscription model or the one-time fee or whatever to pay for the software isn't enough anymore. They want to get that extra juicy revenue from selling user data. Now, this obviously begs the question of how can you tell if your data is being harvested in the first place? Well, if you're using some kind of web-based application, you kind of go into the developer tools of your web browser and you can kind of check kind of the network activity for the specific website. So you could potentially do some checking there to see if there's any odd requests going on. Usually, if you're on a website and you just disable JavaScript, because that solves a lot of problems usually. Well, it can break websites for sure, but usually anything kind of suspicious going on, if you disable JavaScript, usually kind of cuts that out usually. But if you're talking about like desktop applications, you can't exactly do that. So the way that you can kind of get around this is you can use some sort of network packet analyzer like Wireshark to essentially capture all the traffic on your network. Now, while yes, it technically captures everything being broadcasted on your network, Wireshark, at least Wireshark specifically, has a pretty solid and robust filtering tool that you can filter out like all the traffic you don't want. So for instance, all those ARP packets that are going across the network of who has this IP address? I have this IP address. Okay, cool. Who has this IP address? I have that IP address. All that kind of extra traffic. So you can filter all that out with Wireshark, and I'm sure you can with other network analyzer tools. But Wireshark is, I think, probably the best known. So when we're talking about how you can actually investigate this, so you can open up a program that you want to investigate to look for any suspicious traffic that doesn't correlate with what you're doing. So, for example, if you open up a text editor and you start seeing your packet capture start getting hit with packets from said text editor, that might be a potential cause for concern, since I don't think a text editor in general should really be doing much sending back to the mothership, I guess, if you will, harvesting user data. Of course, the tried and true method to make sure none of your applications are, transmitting data back to whoever created them is to be completely disconnected from the internet entirely. Because if your device is completely offline, there's no way for the apps to transmit the data back to whoever developed them. Now, this is a little if you're, this is specifically talking with desktops, of course. If you're on like a mobile device, even if you disconnect Wi-Fi, you still fall back to cellular. But I guess the more blanket statement is if you turn on airplane mode and ensure that you cut off all network connectivity, then that's one way to kind of make sure that your programs aren't transmitting any data that you don't want to. But if you do notice an application possibly collecting data on you, you can either check the settings of the app to potentially disable that. You could just deal with it, or you could find an alternative. Now, one thing to note though, just because an application is transmitting data through network requests doesn't necessarily mean it's, collecting your user data. Now, it's kind of hard to verify this. It obviously is going to be on an app, depending on an app-to-app basis, but some apps would probably use some sort of encryption for their data collection, so you can't actually read what data they're collecting. But if they aren't that savvy and they are transmitting it in plain text, that would be one way that you could easily see exactly what data they're collecting. But also keep in mind that just because an application might be collecting data doesn't necessarily mean it's spying on you. And probably the most common use case for this is apps that report system information to developers. This is pretty common for like Linux distributions, that they'll try to collect data on specifically what hardware you're running, like how much RAM you have, what CPU you're using, what GPU you have installed, things like that, to basically kind of understand what kind of hardware their users are using in order to better target that hardware and provide better support for that hardware. So that's a fairly standard and benign use case for collecting user data. Now, on the flip side to that, though, there's two ways that you can collect that data. One is anonymously, and two is a unique identifier. Now, I think you know which one I would prefer if I knew I had to have data collected on me. I would prefer the one that doesn't have the unique identifier and is sent anonymously. Because the way that the unique identifier works is like the app will essentially create some UUID or something, when it's first installed or whatever. And then whenever it transmits the data back to whoever it's transmitting it to, it would basically attach that UUID. So wherever it's transmitting it to, it can be stored in a database. And then that database can essentially, you can just call a lookup on that UUID and get all the various data on it. But yeah, like I said, just because a app is collecting data about you does not necessarily mean it's doing it in a malicious way to sell to advertisers. But again, it is potentially possible. But again, basically the surefire way to check to see if there's potentially any data collection going on is to use some sort of network analyzer to capture packets and basically look for anything that's out of the ordinary. So if for example, use another example, I guess, because the Notepad one, I mean, that's an app that just shouldn't be, connecting to the internet anyway. But if you do have an app that does have some sort of networking going on, then it's potentially a little bit trickier. But depending on the kind of networking that it does, the types of connections it's making, you could filter those out as kind of like the standard traffic that you would expect. So if you were using, like, say you're using your own like third-party SSH client rather than using the built-in one to like the terminal or something, you could basically filter out all the SSH traffic, because obviously that's the traffic that you want to be doing, so that would be like legitimate and valid. But any other type of traffic, that would be the kind of stuff you would be kind of interested to see where it's going. The other thing you can also do is, if you're using something like Wireshark, you could sort, or you could basically filter based on IP addresses. So any IP address that, like, specifically if we're talking about this SSH thing, any IP address internally, like any internal IP address to your network, you can pretty much safe to say ignore that, and that's, a valid use case. But any IP address that you don't recognize, that would be the potential cause for concern. And again, you can do this with any kind of application too. Specifically, like another example would be like for a web browser. If you wanted to see if your web browser was doing anything funky, you could open it up, go to a website, and then you can basically check what the you can do like a DNS lookup for that website, so you can see the IP address that it should be connecting to, and then there's going to probably, depending on the site you go to, that site is probably going to have some sort of JavaScript or something inside the HTML that's going to try to reach out for to other IP addresses to pull in, like images or other resources. So that would be like legitimate data, legitimate traffic. But any other kinds of IP addresses that you don't recognize, those would kind of be the things that you would definitely want to be looking out for. So yeah, that is your cybersecurity tip for the week. Make sure your programs aren't spying on you. I guess the caveat there, though, is if you want your programs to spy on you, then completely disregard this week's tip by all means. So before we get into some of the nerdy things, I came across a rather interesting blog post this week about a performance comparison between bounds checking and a try-catch statement. So in reading through this blog post, the origin of the idea for this blogger to actually come up with this was actually quite funny. There was a post on Reddit. So the advent of code is going on right now. And if you're not aware, the advent of code is like a coding challenge that usually kind of goes on like every day in December. But or at least up to Christmas. But anyway, the meme was the Drake meme where he's kind of putting his hand out like, I don't want that. And then he points the finger like, yeah, that's the good stuff. It says properly staying in bounds of word search versus putting whole function in try except. So yeah, essentially, should I do proper bounds checking? No, that's not good. I'm just going to throw everything in a try catch and just go from there. So that was the origins of this person's experimentation into is there any kind of a performance hit if you do elect to go that route and say, who cares about the bounds checking? We're just going to throw everything in a try catch. So when it comes to a try catch statements, first off, I guess we should ask the question of why does this even matter? Now, while I could absolutely go on another tirade about memory unsafe languages and bounds checking and all the various potential memory corruption vulnerabilities that can happen, I'm going to spare you this time because I think we've probably beat that horse to death enough, at least for maybe a couple more weeks. But bounds checking as a whole applies to all languages. It's not just memory unsafe languages. Because, yeah, Python is a memory safe language, but if you don't handle bounds checking appropriately, your program is still going to crash. You just don't have the risk of your program potentially being exploited because you went out of bounds. And that's kind of the major difference here. So personally, I never even really considered this as a possible solution of just throwing everything in a try-catch and using that for your I guess, error handling or bounds checking, because, I mean, on the one hand, it is a viable solution because, in theory, your program can't crash if the entire program is just in a try-catch statement. So assuming you're properly handling that catch and kind of getting back into wherever you're supposed to be in the program, it's basically a foolproof solution. Now, it's a lazy solution, but is it the best solution? Since oftentimes, some very ingenious solutions come out of laziness. Think of automation, right? The manual process of having to manually do everything. Someone out there was like, this is way too much work. I don't want to do that much work. I just want to have it done all for me. I'm going to go ahead and write a tool that does it all for me. So just because a solution is the lazy solution doesn't inherently make it not as good as the more kind of in-depth solution. But alas, in this case, the lazy solution is not the best solution, at least according to this guy's testing. So the test was written in Kotlin, which is basically kind of like the new fancy Java, I guess. But anyway, the test showed that the try-catch solution took a 23% performance hit compared to the bounds checking solution. Now, I don't think it should necessarily be a surprise that proper bounds checking is faster, but the exact percent difference in performance may be a surprise because if you've been writing software for a while, and specifically if you've kind of had to deal with any kind of like compiler type stuff or kind of having to understand like how compiler optimizations work and anything like that, it's kind of easy to see why doing the proper bounds checking would be faster, because if you're doing proper bounds checking, it's a lot more optimal because it's a lot easier for the compiler to optimize your code, and thus it's a lot easier for the CPU to execute and predict what instructions are going to come next through branch prediction. So in case you didn't know, CPUs have this feature in them called branch prediction. It was kind of one of the issues, and there was a vulnerability in the branch prediction kind of a while back. Spectre and Meltdown might have heard of them, where essentially if you basically kind of did some sort of it was like a side channel attack of sorts where you could basically trick the CPU into predicting stuff, and then based on there was vulnerability in the branch prediction that basically allowed a threat actor to gather information about other processes going on the system without actually, having access to them, essentially, is kind of what it boiled down to. That's like the super short version of it. But anyway, branch prediction is a kind of an easy way to kind of improve performance that like a CPU provides you, and having a compiler be able to optimize for this is definitely an easy way to gain a lot of performance. And if you're using a try-catch solution, you basically remove all that. But it's not just that, because if you use a try-catch, not only do you lose all the optimization, but you also take a hit in the error handling, because whenever you hit an error, you have to have the overhead of the language having to run, whatever code it has to run in order to gracefully catch that error and then handle it. So, and that's before you can go back to the implementation. Whereas if you're doing proper bounds checking, you just see, oh, this value is larger than it's supposed to be, ignore it. Whereas if you're doing a try-catch, you try to index in and, oh, that's out of bounds, so now let me do whatever error handling stuff has to go on. Let me catch the error. So there's a lot more instructions that have to go on doing the try-catch. But on top of that, when you add try-catches, you also introduce additional code overhead to actually set up the try-catch at a low level. So you can kind of think of this as like spinning up a thread or forking a process or doing some kind of file I/O. Like, the actual code implementation might only be 1 or 2 lines of code, but there's a lot of additional overhead, whether that's in code or operating system calls or whatever the case may be, that adds an additional performance hit on top of, if you were to not use those things, right? Which is why if you try to get into like multi-threaded programming, you kind of have to analyze, is the performance increase I'm going to get from spinning up extra threads or forking processes, is that overhead of doing those things going to make up for it in the additional performance gain and speed of the computation, right? So a good example of this is if you're trying to, compute the sum of 1 to 100, especially with how fast computers are these days, the additional overhead of spinning up multiple threads or forking processes in order to perform the computation faster and then merging the result is probably going to be slower than if you just did it all sequentially. And to be honest, depending on your compiler and depending on if you hard code the value, your compiler will just pre-compute the sum for you and you'll never even spin up any threads, because I did try that one time. But where was I? All this to say, things like system calls to do any kind of file input output or spinning up threads or anything like that. When you do these things, you basically have to make a request to the operating system for resources, and you're basically stuck there until the operating system returns control back to you once it fulfills its request. Now, granted, this happens very fast, but there's fractions of a second that you're kind of sitting there waiting while the operating system kind of does its thing. Now, a while back, we talked about kind of doing a performance comparison between cache hits versus cache misses. And what we found was those minor fractions of a second, when there's a lot of them, quickly add up to be massive time losses, especially with how many operations are happening every second on a CPU, because CPUs these days are clocked in the gigahertz, so it's a lot of operations every second. So yeah, you might only be losing maybe a couple microseconds here and a couple microseconds there, but multiply those couple microseconds by thousands, hundreds of thousands, millions, and it quickly adds up. So that's why if you're really going for performance, you can see why throwing everything in a try-catch and kind of negating all the performance optimizations you get from proper bounds checking can really make a difference. So I'll have a link to the actual blog post down below if you're interested in looking at it yourself. But I definitely kind of enjoyed this story because in addition to wanting to essentially automate everything I can, I do also enjoy trying to optimize things as much as possible and being able to squeeze out every bit of performance from a system that I can. And speaking of that, I guess, let's move into what nerdy stuff have I been up to this week. Now, before we get into some of the programming stuff I got up to, I just wanted to, give a little bit of a PSA, if you will. So, if you happen to have a Bamboo Lab printer with the AMS unit, do not let a spool completely run out while printing. Because if you do, the filament will get stuck and you'll basically have to disassemble the entire unit just to get it unstuck because it won't be able to wind itself back up and essentially get rid of the filament that's in the tubes. Ask me how I know. So I think basically what happened is probably what it was however the filament came from the factory kind of clamped down at the end on the spool. That kind of got itself lodged in the feeding mechanism somehow, and it basically just got jammed and stuck. And it was a fun time of troubleshooting, I guess, if you will, kind of disassembling everything and trying to pull the filament through, and it wasn't going. So then I ended up having to, like I said, basically disassemble the entire unit in order to get it out. So that was an interesting way to spend an evening. But in addition to things that were an interesting way to spend an evening, I had another drive failure this week. So I don't remember when it was last, but maybe a year or so ago, maybe it was a little longer than that. I don't remember. I had a disk failure in my NAS, but this time I had a drive failure in my R620, which is my main hypervisor. So that is kind of a big deal. So ironically, I noticed this when I was also troubleshooting the 3D printer issue. I just happened to kind of be up in the server room, aka office, and happened to notice that one of the disk light indicators was flashing, but not like it normally does when there's disk activity. So I was like, okay, that's a little weird. Let me go check this real quick. So I checked the R620's iDRAC log, and I didn't see anything in there. Although I should note, though, that after I changed the CMOS battery, I did completely clear the log. So it potentially could have happened before this. So to be honest, I have no idea how long this drive failure or this drive had failed. I don't know when it happened. But obviously I didn't notice it because I have RAID or ZFS RAID set up. In Proxmox. So even though I did suffer a drive failure, the system was still able to continue because of the redundancy that ZFS offers, or specifically RAID. So yes, but Proxmox claimed that the disk in question had been removed, which was interesting because it wasn't removed, it was still in the system, which led me to believe the drive was probably dead because it was an SSD, and it might have been dead for a while because it wasn't in the logs for the iDRAC. But at the same time, I'm not entirely sure if it would have even shown up anyway, because even with the drive being dead in the R620, it didn't complain. But the second I removed the drive, it complained that the drive was removed. And then when I put the dead drive back in, the error went away and it said, yeah, the drive got reinstalled. So not probably wouldn't have even shown up in the iDRAC log, even if it did die before the CMOS battery logs got cleared. But yeah, part of me was kind of wondering that maybe this was because I pass all the drives directly through to Proxmox. Maybe that had something to do with it. I don't know. But I ended up ordering a replacement drive, which happened to come this week. It was a pretty quick turnaround, which was very nice. But in the meantime, I did toy with the idea of using one of the drives for my other hypervisor, since the drives installed in both that hypervisor and my R620 are identical. So, and plus I'm not actively using that hypervisor at the moment, so it would have been easy to just kind of steal one of its SSDs and make that have a degraded state and then rebuild the R620. But then I kind of decided, no, I don't really want to do that because then I'd have to rebuild 2 ZFS arrays rather than just one. So I decided to risk it and just wait for the drive to show up. And thankfully, like I said, the drive came pretty quickly, so my risk and my gamble did pay off. I did not suffer an additional drive failure. But the process of getting it swapped out was fairly easy and pretty straightforward. Literally all I had to do was remove the old drive from the R620, unscrew it from the caddy, screw in the new one, pop it back in, and start rebuilding the array. I did have to kind of in ZFS tell it to swap out one drive for this new drive, but once I did that, it started rebuilding the array right away, and I didn't even have a single second or even fraction of a second of downtime, which was absolutely incredible. I'm basically a full-blown data center up here. I'm basically the cloud, zero downtime, even when there's a hardware failure. While I do kind of make light of that, that is, one of the reasons why us home labbers do this, right? To basically have a kind of data center thing with trying to maximize uptime, which to me was pretty awesome. And one of the nice things about the R620 is those hot swappable drives in the front means I didn't have to shut the system down. And even when the ZFS array was rebuilding itself, all the services and all the virtual machines and everything was still up and running, and I didn't notice anything. And usually, if there is an issue with the R620 when it comes to virtual machines not being up, or there being so much latency and lag on the system that it can't process things, I will get a notification from my Notify server running in the cloud that my home lab is down, but I did not get any of those, and I should have gotten one if there was an issue, because this ZFS rebuilding, while it didn't take long, it definitely exceeded the length in which the notification server would have notified me, because the notify server is set to check in essentially to my home lab every 15 minutes. And if the home lab isn't up, it sends me a notification. And the rebuilding process, like I said, it was pretty quick. I think it took just under 20 minutes. I think it was like 19 minutes and change, which to be honest was pretty quick in my opinion, but I guess that's SSDs for you. But when I tried to rebuild my NAS, like whenever that was, granted there was probably at least twice as much, if not 3 times as much data on the NAS, so of course it's going to take longer. But from what I recall, that took like hours, if not maybe a day or so, to actually complete, which again, that's hard drives you have to thank for that. So basically hard drives versus SSDs. SSDs are definitely a lot quicker. But I touched on at the beginning, there's a first time for everything. And I have to say, this is the first time I've ever actually had an SSD fail on me before. But like I said, I guess there's a first time for everything. But then now let's get into some of the programming that I got up to this week. So I touched on last week that was going to continue kind of working on this config solution for my video game. So the solution that I ended up coming up with for this was to create a map, specifically an unordered map, for the config solution. Now, the first attempt, I made a map, and so the key was essentially the string value of the config option. So for instance, the string would be screen width, screen height, keyboard keys, all that kind of stuff would be like the various key in the map. And then the value of the map would be a pointer to the variable that I wanted it to represent. So essentially what that would allow me to do is basically index into the map and set whatever value equal to it, and that would set the value to the value it was pointing to, which happened to be the config option that I wanted to set. I know that probably makes absolutely no sense because I wasn't able to draw it out for you, but needless to say, it made me able to, in one line, be able to set the appropriate variable that I wanted to set rather than having a massive if-else tree. So definitely a lot more concise, a lot more manageable. The only problem with this solution is it limited me to a single variable type. In this case, it was an integer, and that wasn't really ideal because I'm not sure about you, but if I am a end user and I want to update my config file for keyboard keys, I don't want to have to type in some arbitrary number for the appropriate keyboard combination, right? Like if I want to, say, set the letter A as the A button, I don't want to have some number memorized that, oh yeah, the A key maps to 47, or the A key maps to 89. I don't actually know what it maps to, but something like that. That's not very user serviceable. Alternatively, having it be a string value and trying to convert that into an integer value, that would take additional functions and processing, and it wasn't a very good solution. Like it had some promise, but there were some massive trade-offs. So in comes my second attempt. So my second attempt, I think, is a lot more of an elegant solution. So it takes basically the same idea from the first solution, but instead of mapping to the pointer to a variable, so in other words, rather than specifically setting the variable that I want to set, it instead calls a function which then sets the variable that I want to set. So this way I can have it, basically be a custom solution with a standard input. So the input is always going to be a string value because we're reading the data from a text file. So all the data coming in is going to be a string. So basically what this map will do is it takes the key value in this, say, for example, screen width, and then that maps directly to the set screen width function, which then I can pass in the parameter, whatever the value happens to be for the screen width, and then parse it appropriately. So this allows it to be a lot more modular, but you also kind of keep the same one-line solution cleanliness, so you don't have the massive if-else tree. But then you can also add the complexity for the various config types. For example, the keyboard one, I'm still trying to identify how I want to convert that, with the whole human readable thing. But it's going to be a lot easier because I don't have to change any of the core code. I just have to change the code specifically on how to handle parsing of the value coming in for whatever key is trying to be set. So it's definitely a lot better approach in my opinion. But I did touch on there my solution for converting essentially the keyboard values so they're both human readable and program digestible. Because of course programs like things in terms of numbers and humans like things in terms of words. So like I said, having a number in your config is not as understandable as having a word like key A, for instance, rather than the number 89. It's a lot more easy to understand key A, what that means. So currently what I'm thinking of for my solution is to basically create another map that maps directly from all the possible key config options that Raylib provides, and mapping that to basically a string representation of it to what its actual representation is, and then kind of vice versa. So I can either give it a string and it will give me the number associated with that enum value, or vice versa. I can give it the enum value and it will spit out the string. So I can basically just index into the map and it'll return, well, I guess probably have two maps then in that case, one for the string as the input and one for the string as the output, so two maps. But in either case, I would basically be able to give it either the string and it would give me the number, or I could give it the number and it would give me the string. So that's what my current approach is. I'm planning on doing, but haven't had time to get around to do that. Probably because I did two implementations of the config file, one being with the variable solution and one being with functions. But I'm definitely happy with the progress that's being made, and I think it's definitely going in the right direction. Now, the last thing that I wanted to touch on for this week is the Xserve. Now, you guys know that how obsessed I am with Apple's Xserve. Probably, maybe I'm obsessed a little too much with it, but if you're unaware, which if you've listened to the podcast for long enough, you're probably well aware of what the Xserve is. But if you're new, first off, welcome. But second, the Xserve was kind of Apple's sometimes forgotten rack mount server that they made in the early 2000s. Now, it just so happens that I always seem to bring up the Xserve every now and again. And usually it's either a topic, like in today's case, it's actually a topic, or other times I'll be talking about something completely unrelated. I'll mention the Xserve and then I'll go on a mini tangent just talking about it for basically no good reason. But this time I actually have a good reason to talk about it. So according to the information, Apple is allegedly working with semiconductor company Broadcom to create its first server chip designed to handle AI applications. So let me recap that real quick for you and read it again slowly. So Apple is allegedly working with semiconductor company Broadcom on its first server chip designed to handle AI applications. So the key word there being a server chip. Now, you know what computer Apple used to make that used a server chip? No, not the Mac Pro. Well, yes, it technically also used a server chip. That's not the one we're talking about. The Xserve. The Xserve used server chips, specifically Intel Xeon line, back when it existed, and it was an actual dedicated server meant to go in a server rack in a data center, not that Mac Pro rack mount thing. That's kind of its own hodgepodge thing, but the Xserve was a legitimate purpose-built server meant for data centers. It wasn't a let's just put Rails on this desktop and call it a server type of a deal. But again, according to the reports, these chips are internally codename Belantra, I believe that's how it's pronounced, and they're specific server chips designed for AI. I mean, unless you've been living under a rock, I'm pretty sure you know at this point that Apple has been pushing Apple Intelligence like there's no tomorrow, and having dedicated chips in their cloud to be able to handle the various AI applications. That I think you can kind of see why they want to do that. But a source told the information that Apple aims to complete the chip design within about 12 months or so. So I don't know about you, but which granted that is a very big if, Apple comes out with a server chip in the next couple of years, I mean, is there a chance they put it in a legit server, like a full rack mount server like the Xserve, and basically resurrect the Xserve? I mean, I don't know about you, but that would be pretty freaking incredible if you ask me. Now, I'm going to tell you right now, if this actually happens and they come out with this server chip and they put it in a dedicated rack mount server and basically resurrect the Xserve and sell it on apple.com, I think there is a very strong likelihood that I might be pulling the trigger on it. Is it going to cost an arm and a leg? Probably. But will I buy it? Probably. Now, granted, I might depend. I guess it depends on how good it is and whatnot. But I might potentially try to hold out until it kind of comes up on the secondhand market on eBay. But we'll see. Now, if their solution for this server chip is to basically just stick it in a Mac Pro and do some kind of rack mount Mac Pro solution, I'll probably pass on it. But I'm not saying that Apple is going to revive the Xserve here. That is pure speculation on my part and kind of wishful thinking on my part. But if the rumors are to be believed that they are working on a server chip designed for AI, I think it makes sense, and it's a golden opportunity for them to resurrect a dedicated server line that they used to produce with this server chip. Now, to essentially resurrect their best product line ever, that of course being the Xserve. Now, of course, I'm not talking about in terms of the sales perspective, because I'm pretty sure the Xserve was not their best-selling Apple device ever. I'm pretty sure it falls way down in the list when it comes to best-selling Apple computer. But I'm talking specifically from the coolness perspective, because, again, it doesn't matter. You can basically ask anyone, even folks that aren't Apple fanboys, on what they think of the Xserve, assuming they actually know what it is, if they've seen one in a rack. Almost everyone will tell you that it is one of the best looking servers that has ever been made, because it quite frankly just does. And since, if you remember, we also have discussed that if a product looks good, it instantly adds an additional 10 to 20% performance increase, right off the bat immediately. That, of course, is a joke. But, I mean, the coolness factor can definitely not be ignored. So, again, this was basically me kind of just trying to wish something into existence. Again, these are just reports about this server AI chip. Apple, of course, has not announced that they are working on a server chip designed specifically for AI. But again, I think we do have to take a step back. Mainly, I'm talking to myself here. We have to take a step back and pump the brakes, because if we recall, literally all a server means is basically a computer dedicated for a specific task, right? You can have a traditional desktop computer be a server, so a server does not necessarily mean that it's going to be in a rack mount enclosure in a data center in a rack somewhere. It just means it's going to, serve a purpose to do a thing, right? But I'm hoping, because they use this verbiage of it being a server chip that they actually put it in a real server and resurrect the Xserve. Again, I don't think it's very likely that they will resurrect the Xserve with this server chip, because especially with kind of Apple's focus nowadays. I think if you look at, I think it's what's the company? I think it's Mac Stadium, I think, is the company that essentially has data centers full of just like Mac Minis and like Mac Studios. And I think kind of like the Mac Mini market is kind of really what Apple kind of focuses kind of their quote-unquote servers for. Like if people want an Apple server, they pretty much just go with a Mac Mini, and there are literally data centers, like I said, specifically with Mac Minis for that purpose. So I'm not sure if the Xserve there's even a chance that it could be resurrected, but a man can dream, right? So yeah, this whole segment was basically an excuse for me to talk about the Xserve and to just kind of hope that the Xserve can be reborn, because I think like I said, I think it's a golden opportunity that if they are specifically working on a dedicated server chip, I mean, at least to me, it only makes sense that you put it in a dedicated server. And what previous dedicated server did Apple used to make? The Xserve. So I think they should go ahead and bring that back. So Tim Cook, if you're listening, do a man a solid and bring back the Xserve with this server chip. But speaking of chips, let's get back to our trivia question before we wrap up, because that also was dealing with chips. So the CPU stands for the Central Processing Unit, and GPU stands for Graphics Processing Unit. But what does APU stand for? If you said Accelerated Processing Unit, congratulations, you got this week's trivia question correct. And even if you didn't get this trivia question correct, I hope you at least got 2/3 of it correct, because processing unit was kind of the same thing across all three of those. So hopefully you got at least that part right. But if you got the whole thing right, props to you. And if you enjoyed this episode, definitely be sure to leave it a rating and review, and subscribe if you haven't done so already. And be sure to share it around with any friends or family members. And if you have any questions about this episode, or have any topics, ideas, comments, or anything, or ideas for future episodes, you can shoot me an email at contact@darkassassinsinc.com, or you can leave a comment down below if you're on YouTube. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.